Today we're going to prove that the limit as x approaches 0 plus of the natural log of x equals to minus infinity. We all know how the graph of the natural log of x function looks like. This is the graph of the natural log of x, and as you can see, as x gets closer and closer to 0, the function goes to minus infinity. And well, look at this plus here. 0 plus, what does it mean? Well, it means that x approaches 0 from the plus side, so from the right and not from the left, because the function is not defined for x less than 0, so it doesn't make sense to say the limit as x goes to 0. We have to specify that we are approaching 0 from the right. So how are we going to prove this limit? Well, there is a very precise statement to prove it, and I'm going to explain you intuitively how it works, and then we're going to prove it. So to prove this limit, we have to show that given any number m greater than 0, there exists a number delta greater than 0 such that if x is in the interval 0 delta, we have that our function f of x is less than minus m. But what does it mean? Firstly, let's take a look at this limit. We are approaching 0 from the plus side. So it means that if x is in an interval 0 delta, so this is the interval 0 delta, we're going to have that f of that particular value of x, so if this is x and it is within that interval, we're going to find that f of that particular point x is less than a value m minus m, because we chose m greater than 0. But what this means is that for every m greater than 0, so m can be any real number, there's always going to be a delta such that x within that interval is going to give us f of x less than minus m. So this is a precise statement to say that as x gets closer and closer to 0, f of x becomes bigger and bigger. So let's try to prove our limit. So given m greater than 0, we're going to find a delta equal to, we still don't know, but what delta is going to be, but it depends on the choice of m, so it is going to be a function of m, such that if x belongs to this interval, in other words, if x is between 0 and delta, we're going to have that f of x is less than minus m. So natural log of x, our function, is less than minus m. So let's try to kind of solve this inequality. So we have the natural log of x is less than minus m. So to solve this inequality, we first have to get rid of the natural log of x. This is very simple to do, just e to the natural log of x and e to the minus m. So just e to the both sides. So we're gonna get e to the natural log of x is just x, and this is less than e to the minus m. But remember that the argument of the natural log function has to be always greater than 0. So we shouldn't forget that when we apply e to both sides. We know that x is simultaneously less than e to the minus m and greater than 0. So x has to be between e0 and e to the minus m. But now we have to find a delta such that if x is between 0 and delta, we're going to have that x is between 0 and e to the minus m, because this is just this inequality solved. And what delta here implies all of this? Well, if we choose, for example, delta to be equal to e to the minus m, so let's find out whether it works. Well, 0 is less than x, that is less than delta, but delta equals to e to the minus m, because that has to be a number greater than 0, and e to the minus m is always greater than 0, because this is simply equal to 1 over e to the m. And for every m greater than 0, this is greater than 0, and it's also greater than 0 if m is less than 0, but we do not care about it. And this implies that 0 is less than x, that is less than e to the minus m. This is true, this works, and this is the same as saying that the natural log of x is less than minus m. So it works, and we proved that the limit as x approaches 0 plus of the natural log of x equals to minus infinity. If you enjoyed this video, leave a thumbs up, share it with your friends, don't forget to subscribe to my channel, and as always, until next time, bye.